Hello everyone, welcome back to JD Science Prep. Today we will be discussing a little section of refraction called the critical angle. So it says the critical angle of a boundary is the angle of incidence that causes the angle of refraction to be 90 degrees. So if the angle of refraction is 90 degrees, the refracted ray runs directly along the boundary between the two mediums. So let's take a look at this diagram here with that in mind. So we'll just draw a few lines on this diagram and we'll make some labels and we'll try to make some sense of this. So first off, we have our incident ray right here. So this is our incident ray. And over here, we have our refracted ray. This white line right here, this is going to be our boundary. And finally, this dotted line, you can probably guess, but this is going to be our normal. I'm just going to make that a little bit neater for us here. This is going to be our normal. Okay. So we said that the angle of refraction is going to be 90 degrees. And in this diagram, that looks correct. So we have our angle of refraction here. Remember, it's always measured from our refracted ray to our normal. That looks like a 90-degree angle to me. And finally, this angle right here, so where I just drew that arrow, this is going to be our angle of incidence, but since our angle of refraction is 90 degrees, this is going to be our critical angle. So again, the critical angle is the angle of incidence that makes a 90-degree angle of refraction. Okay. So what we can do with this, we don't just have to draw diagrams, we can actually calculate the critical angle of different boundaries. So it says we can calculate the critical angle of a boundary between two mediums because we will have the following information, as long as we know what both mediums are. So we'll have the index of refraction for our first medium, index of refraction for our second medium, and finally we'll also have the angle of refraction, or theta 2. And if you guessed that this is going to be 90 degrees, you are correct. Okay, so our theta 2, whenever we're looking for our critical angle, is going to be 90 degrees. So with all of this information, we can use Snell's law, capitalize the S, Snell's law to figure out our critical angle. Okay, so just a quick hint before we jump into our one and only example in this video. So it says the critical angle can only be calculated if the light is traveling from the slower medium to the faster medium. So in other words, your N1 has to be greater than your N2 or else it will not work. Okay, so example 1, our only example of this video, it says calculate the critical angle of a plexiglass water boundary. So it doesn't give us a ton of information here, but let's figure out what we have. So first off, remember our little hint from before. I'll just scroll up and show you. The critical angle can only be calculated if the light is traveling from the slower medium to the faster medium. So remember, the higher the index of refraction, the higher the index of refraction, the slower light moves through it. Okay? The slower light moves through it. Okay, so we'll keep that in mind when labeling our N1 and N2. So again, let's take a look here. It says that our boundaries between plexiglass and water. So plexiglass has an index of refraction of 1.51, while water has an index of refraction of 1.33. So according to our hint, our N1 has to be the greater index of refraction. So we'll say it's 1.51. Our theta 1, we do not know. Okay, remember that is our critical angle that we're trying to calculate. Our N2 is 1.33 from the question. And our theta 2, if we're trying to figure out the critical angle, will always be 90 degrees. All right, so let's just set this up in Snell's law again here. So again, we have N1 multiplied by sine theta 1 equals N2 multiplied by sine theta 2. Let's fill in our variables here. So we just have 1.51 multiplied by sine theta 1 equals 1.33 multiplied by sine of 90. So for any of you that are familiar with using our sine value here, you'll know that sine 90 is just equal to 1. So if you want to substitute 1 for sine 90, feel free to. I'll leave it in here. So let's isolate for what we want. We want to isolate for sine theta 1. We want to isolate that. So let's divide our left side by 1.51 and our right side as well by 1.51. And let's type that into our calculator. So our sine theta 1, let me just type it in really quick. So we have 1.33 multiplied by sine of 90, or 1. And that is divided by 1.51. We get a large, or a very small decimal number here, less than 1, 0.8807947. And all we have to do with this number here, remember back from our Snell's law video, we'll just take the inverse sine of this number, to get our angle here. And you get a theta 1 of 61.7 degrees. So 61.7 degrees. Okay. So that will be our critical angle. Whenever light hits a plexiglass water boundary at 61.7 degrees, our angle of refraction will be 90 degrees. Okay, so 61.7 degrees is our critical angle. And that is a video just giving an introduction to critical angle and how to calculate it. I hope this video has helped.